Okay, so homework 7, exercise 7 was one of the top requested problems. And I think probably part of the reason why it was so highly requested is that we were just learning about null hypothesis and hypothesis testing. And then this problem looks like a fit stat schema, but that pattern matching isn't quite right. What we're going to use for this problem is that this is going to be a Bayes theorem problem. And let's recall what Bayes' theorem says. It says that the probability of A given B, and what we want to know is whether we got a heads given that we see this kind of data, is going to be equal to the probability of B given A times the probability of A, all divided by the probability of B. Okay, so we want to identify these, say what's what, and so on. So what do we want to know? A is going to be the event that we flipped a heads. We flipped our coin and it landed on heads. And what is B? B is we see the data. Right? We see those samples. That data which is like 3, 6, 3, 3, etc. Okay, and of course we could see data that looks like this from either of these two things. So just by seeing the data, we can't immediately rule one of them out. All right, so what are we going to do? Well, we're just going to try and figure out, well, what's the probability of seeing this particular data given what we have. But we can work with some extra information, which is what's the probability that we flipped heads? Well, we're told here that we have a fair coin. So the probability that we flipped heads is going to be just 1/2. So we have that part. And then we're going to say, okay, well, what's the probability of B given A? What's the probability that we see this data given that we flipped heads? All right. And so we can figure that out next. The probability of B given A is going to be, okay, well, the first thing we need to have happen is that we sample from our geometric distribution and we get a 3, which means we failed twice and then we succeeded once. So this is going to be 2/3 to the power of 2 times 1/3 to the power of 1. That's sort of going to correspond to this 3 here. And then not only that, but then also independently, we have to, on our next try, we have to get this 6 here. That's not how I want to write the 6. We want to get this 6 here. And so what's that going to look like? That's going to look like, well, we fail 5 times in a row and we succeed on our 6th try. All right, that's our orange one. Okay, and so on. That's our probability of getting this particular list of 10 samples, given that we're drawing from a geometric distribution. Okay, so we can figure out what this is. We're going to figure this out in R. We're going to compute in R. Okay. Next, to find probability of B, we're going to use the fact that the probability of B is going to be the probability of B given A times the probability of A plus the probability of seeing B given that we get tails times how often we get tails. All right, and I want to emphasize, we know a bunch of this stuff already. This thing is 1/2. This is 1/2. That's the probability of I've written this wrong. This should be an A complement. This is the probability of getting heads and of getting tails. This here, we just said that we're going to compute in R. So that's star. And this here, we're going to also compute in R, but it's going to be a pink star, rather a red star. And what's this? What's the probability of B given A complement? Well, it's what's the probability of drawing all of these numbers from a Poisson 3 distribution. So that lambda is equal to 3. And so we have to remember, well, how does that distribution go? We're going to have now 3 to, there's lots of 3's here, but we'll clarify what's what. 3 to the power of 3 divided by 3 factorial times e to the power of minus 3. And let's highlight what these are. Let's highlight what these are here. So the 3's that we care about is going to be, well, let's actually just illustrate it on the next one. Times, now on the next one we get 6. So this is going to be lambda to the power of 6 divided by 6 factorial times e to the minus lambda. All right, and we're going to compute this in R2. In fact, we're not even going to do it directly in R. We're just going to ask R for d plus, right, which will give us what we want. Let's make this a little bigger. Okay, so this is what we have here. All right, then we're going to compute these things. We'll have all of the different pieces, and then we'll be able to say, okay, what's the probability of A given B? Okay, so here's our data from the previous slide. And the first thing that we want to know is we want to know, well, what's the probability of B, maybe I'll just write it this way, probability of B given A. And what's that going to be? Well, the first thing to keep in mind is that means we're sampling from a geometric if we got that heads. And geometric cares about the number in R, cares about the number of failures, not the number of trials. So when we're using built-in things for R, we actually want to look at data minus 1, which subtracts 1 for everything, right? Which shifts that perspective from the number of tries to the number of failures. And then we just want to say dgeom, that data minus 1 and 1/3. And then that will say, okay, that's the probability of getting each of these individual observations. And then we just want to take its product, which is this really tiny thing. And I'm going to call this P of B given A, a really long name. Okay, and we also want to look at the probability of B given A complement. And that's just going to be similar, except for instead of using pgeom, we're going to use, or dgeom, we're going to use d plus. And then Poisson uses the same definition that we do, so we don't have to change the data at all. And then that it's given to you that lambda value is 3, and so we can look at these two values. So that's the probability of seeing this thing with a heads, and this is the probability of seeing this thing given that you got a tails, and so the Poisson's looking a little bit more likely here. Okay, and now what do we want? We want the probability of A given B, and this is going to be the probability of B given A times 1/2. That's in our numerator. And then in our denominator, we're going to have that same thing, probability of B given A times 1/2, plus the probability of B given A complement, which is also times 1/2. And that's going to tell us our probability of A given B is about 5%. So the probability that we have heads, given that we see this data, is something like 5%, and the probability that we got tails, of course, is 1 minus that, so it's about 94.5%. Okay, and so that's the answers that you're looking for. In particular, the question is, what's the probability I flipped heads? And so given that you've seen this data, there's a 5.4% chance that you had flipped heads.